Hello guys. Today we're going to be looking at the symmetry of roots of quadratic equations. Now, in order to bring out this topic, we're going to start by solving a simple quadratic equation. So let us say we have x squared plus 4x plus 3 equals 0. All right. To factorize this, we would have gone AC. Now in this case, A is 1, so I'm going to have 3 here. All right. So we want two numbers. When we multiply them, we get 3, but when we add them, we get 4. So this is going to be x squared plus x plus 3x plus 3 equals 0. All right, breaking this down, I can pair these two and I can pair those two. All right, here we have x being common. So if I factor that out, I'm going to have x plus 1. In the second pair, we have 3 common. So if we factor that out, we're going to have x plus 1 equals 0. All right, so this is going to become x plus 3 times x plus 1 equals 0. Now there's a special name that we give to these here. These are called factors. All right. So the principle is that if we have two things being multiplied to give us 0, one of them must be 0. So it means now that either x plus 3 equals 0 or x plus 1 equals 0. If this is so, then x is either negative 3 or x is equal to negative 1. Now, there's a special name that we give to these as well. These are called roots of the equation. All right. Now, what is special about roots? If we were to put this on a Cartesian plane, because the x squared is positive, of course, this would have a minimum turning point. So let us say we have negative 3 there, and we have negative 1 here. These 2 points represent a point where the graph would actually cut the x-axis. All right. Now, the constant in the equation is where the graph would cut the y-axis. So the constant up here was 3. So this graph would actually cut the y-axis at 3. But we're not so focused on that now. What is unique about where this graph cuts the x-axis? It means that the y value is 0, or f of x is 0. That is where we get the roots of the equation. All right, now that we have the roots, let us see if we can actually reproduce the original quadratic equation. All right, so let us start with the roots. The roots are x equal negative 1 and x equal negative 3. These are roots. Now, of course, if we have roots, so my factors here would be, if I bring that one over, I'm going to have x plus 1, and I'm also going to have x plus 3. These would be my factors. All right. Now, to get the original polynomial, we're going to combine these factors. So we're going to have x plus 1 times x plus 3 would be equal to 0. Now, if I expand this, I'm going to end up with x squared plus, if I multiply this by this, I'm going to have 3x plus 1 times everything would give me 1x, which is just x plus 3 equals 0. So breaking this down, I have x squared plus 4x plus 3 equals 0. Now, what is so unique about this? What we have just done is to use the roots of the equation to produce the original equation. We know that generally the quadratic equation has the form ax squared plus bx plus c equals 0. So if we can use the roots to produce the equation, there must be a connection between the coefficients and the roots themselves. So let us try to generalize this then. Let us call the roots alpha and beta. All right. If those are the roots, automatically I can produce my factors. So my factors would be x minus alpha and x minus beta. Using my factors, I can take the product to produce the original equation. So we can say x minus alpha times x minus beta is equal to 0. All right. Now if I expand this, I'm going to have x squared minus beta x minus alpha x plus alpha beta equal to 0. All right, let's break this down. So this becomes, I can factor out an x and a minus sign here. So I could have x squared minus, all right, let's turn this around, alpha plus beta times x plus alpha beta equals 0. All right, and bear in mind that the original equation has the general form ax squared plus bx plus c equals 0. Now the coefficient of x squared in this one is 1. So I would want the second equation to look the same so I can get an effective comparison. So we could divide the entire equation by a. So I'm going to have x squared plus b over a x plus c over a equals 0. Of course, if we divide 0 by anything, it's still going to be 0, apart from 0, of course. So now I can actually make this comparison now. So by comparison, are we comparing the red box, which is what is down here, in the green box. All right, this is all we can say. Now, notice up there we have negative alpha plus beta, which really means the sum of the roots. So we are saying that the negative of alpha plus beta is equal to, looking at x, the coefficient of x down here is equal to b over a. And the constant up there, which is alpha beta, is equal to the constant down here, which is c over a. Now note that we can actually simplify this to say that alpha plus beta, which is the sum of the roots, is equal to negative b over a. Now what this is showing me is a connection between the roots themselves and the coefficients of the equation. Very powerful. All right. So let me make some notes here. This here is the sum of roots. And down here, or over here, we have the product of roots. And these are the two most important things here that we're going to be using to do every single thing we do in quadratic equations. So let me put that in yellow. Very important that we highlight this area right here. All right, let us start out with how useful this is. What I can simply do, I can say to you that a quadratic equation, so a quadratic equation has roots 1/3 and -1. Find the equation. Now, in this case, I wouldn't have to go through the entire step of finding the factors, then multiplying them to find the equation. We simply go back up here where we had find a general equation already. In red here, we say it's x squared minus alpha plus beta, which is the sum of the roots, times x plus alpha beta equal to 0. So that is the same concept we're going to apply down here. So let me start by writing the general form. We can simply say x squared minus open bracket sum of roots times x plus product of roots equals 0. And that is what we use to do everything. The roots here are 1/3 and -1. So the equation is going to become x squared minus 1/3 plus -1 times x plus the product of the roots. So it's 1/3 times -1 equals 0. All right. And all I need to do here is break this down. So it becomes x squared minus -1/3, well, 1/3 plus -1. That is going to give me -2/3 times x plus, well, you have 1/3 times -1, so that's plus a -3 equals 0. All right, now if I tidy this up, I'm going to have x squared, removing the bracket, I'm going to have plus 2/3 x minus 1/3 is equal to 0. Now this doesn't look pretty tidy. So we have fractions here, so I could find the LCM. And in this case, my LCM is 3. So what I would want to do is to multiply this entire equation by 3. Now when I multiply all this by 3, it's going to become 3x squared plus 2x minus 1 equals 0. And this is my equation.